Okay, we're going to be talking about special right triangles. We're going to start out by talking about the 30, 60, 90. These triangles are going to be very instrumental when looking at trigonometry and also when looking at the unit circle. So with the 30, 60, 90, what we have is we have these values in here for x radical 3, x, and 2x. Now when we're talking about the unit circle, x is actually going to be equal to 1. Which would make this 1, 2, and then radical 3. The way I remember this information is I have 3 different angle measurements, therefore it's going to be a radical 3. And again, this can be used for all triangles that are 30, 60, 90. The other special right triangle that we deal with is called the 45, 45, 90. And as you can imagine, since it has 2 of the angle measurements that are the same, we are going to have an isosceles triangle. So when I look at the 45, 45, 90, and again I'm going to put this and try to put this in respect to how we would be looking at it on the unit circle. All right, I would have looking like this. This would give me my 45-degree angle. Here's my right angle, here's the other 45 degree. So what I would have here, my x, and then this would be x times the radical 2. Now the way I remember this is because I have 2 different angle measurements. That's how I remember the radical 2. Remember in the 30, 60, 90, 3 different measurements of degrees, and we have a radical 3. In this one here, it's 45, 45, 90, and I only have 2 different measurements, so it's radical 2. And again, this will be used and implemented when we are working with any type of trig problems that have to do with this. For example, the 45, 45, 90, if I took a square and cut it in half, I would have 2 congruent 45, 45, 90s. And the 30, 60, 90 is helpful when taking an equilateral triangle and splitting that in half. So what we see here is I've got the measurements, and again, if this was the unit circle, that would be 1, 1, and radical 2 would give me the length. And again, why you're using that information in the unit circle is whenever you're finding any of the trig functions, whether or not I'm looking at this angle and I'm trying to find sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, or my tangent, which is opposite over adjacent. All of this information, very helpful when doing any trig problems and also working on the unit circle.